Hello and welcome to a new episode of Mostly Engineering and another part in our Enigma Build series. And amazingly, we already came so far that the rotor is more or less done. All the big components are finished and working, and the only thing we have left to do is do the wiring and manufacture all the pins. And the pins are more or less very straightforward parts, so easy to manufacture on the lathe. No problem there. The only complication with the pin is that we need a lot of them. So for the spring-loaded pins, we need 26, and for the other pins, we already need 52 of them. And this will take a lot of time to manufacture them. So the side project of today will focus on some lathe improvements that will speed up this process. And when we manufacture these parts, there are basically two components to the equation. First is the cutting part, and there we can't really do anything to speed up the process. If we take faster cuts, if we take deeper cuts, worst case it doesn't work at all. We may damage the part or our tooling, and in the best part we will get a horrible surface finish. So this is not really an option. But the other part is where we have to make sure that we hit our dimensions and we hit our tolerances. And that means measuring. And at the moment we have to take our calipers, stop the machine, then somehow get our calipers on the part in this really tight space between the part and the tooling and everything, read off the measurement, then remove everything, start the machine again, take the next cut, check again, takes the next cut, check again, until we hit our right dimensions. So that takes up a lot of time. And so our lathe improvements will focus on cutting down this measuring time. So let's go over to the lathe and I'm going to talk you through my plans. So here we have our little lathe, and let's talk you through the improvements I'm planning to do. So first of all, we have here, a while ago I already made this indicator holders, and they will allow us to, this one goes over here, so they will allow us to measure the movement of our sled directly. Gives us two great advantages. So first of all, when we measure the movement directly, we don't get a measurement error reading off the scale, because here we have some slight backlash due to the gearing. This is history then. And second of all, and for speedy manufacturing, to make this more efficient, doing it this approach, we can measure while the machine is running, and that will save us a lot of time. But you see the problem here. So this is the indicator position, and at the moment the sled is not able to reach our indicator. So we will machine a little piece of aluminum to extend the reach so that we can fit our indicator, and we will do the same for our cross slide over here. Very nice, easy and simple. And the second improvement I want to do is to get rid of measurements altogether. And to do this, we need to machine some stops. So one stop will go in here, so that then we can run the machine and we will just run into the stop, and now we have the measurement. So this stop will be really easy. We just copy the same principle as with the tailstock. Here we have the profile of our machine bed and a second part, and by tightening down the screw we will clamp the stop to our machine bed. And this is easy peasy lemon squeezy. Our machine bed is made from hardened metal, so our aluminum won't mar our precision ground surface over here. It's easy. The problem is, where I'm not sure that I even want to do it, is to design a stop for our cross slide, because as you see here, this is made from aluminum as well. So clamping something to here might damage our surface, and that's not good. And second of all, the only design so far I can come up with is that we make a dovetail over here, and then some screws here that push the part up so that it clamps against the dovetail. But this design would mean that we put a lot of pressure on these edges, and again, aluminum out of aluminum, so we have a relatively high chance that we would damage both surfaces, and I'm not want to do this. So if you maybe have a design that works, please let me know. Otherwise, I'm probably just going for the indicator approach that we can read off the measurement over here. So that are basically the improvements I'm planning to do. So let's take some measurements and then go back to the computer and draw our parts. So, and here we have our model parts. The two parts here are for our indicator rest, and then the two parts to make our machine stop. The screw holes are not modeled because we will do this on the mill, so no need to model them here. And slight complication was just to measure the bed. So let's take a short look of it. The rectangular side was pretty easy because just put the calipers on it and read off the measurements. The angled side was a little bit more complicated. Due to the angles, we don't really have a nice vantage point to measure against. So we have to take some assumptions. So we verified that the heights are exactly the same. Then we could easily measure that the width is also 11 millimeters like on the other side. And we could measure that this flat here is 2 millimeters. And then we just assumed that this is a 90-degree angle because it looks like one, it seems sensible. And from there, we derived the other measurements. If this is correctly, we will see when we have the finished parts. So let's go to the CNC, finish the parts, and have a look on them. So, and here we have our CNC part. So first our indicator rests for the cross slide. The indicator will sit on this surface, and here we will glue in 3 magnets so that our part can just clip onto our cross slide. We can adjust its position, and if it's not needed, we can remove it with no problems whatsoever. So really nice, no issues over here. Same is true for the indicator rest that will go on our support sled. Unfortunately, this part of our lathe is made out of aluminium, so our magnet trick won't work. But fortunately, this part will be in a position where it's never in the way. And also we never have to adjust its position. So what we are going to do is we put some super glue on here and then just glue it on place. And we will be fine as well. Very nicely. And then we have our stop. So the top part over here with the profile of our machine bed came out really, really nicely. And then we have what is presumably the most simple part of them all. And here we ran into some issues. So first, while we're cutting these pockets over here, our cutter overcut a little bit. So we got these 2 nicks in the part over here. This is just a cosmetic issue and doesn't look nice, but it won't inhibit its function whatsoever. So we can very nicely live with it. The second problem arose when I put it in our vise in order to drill the holes and then tap them. And during this process, this part shifted a little bit without me noticing. And therefore, this screw goes in crooked. As you can see, it's not straight anymore. And so if we would try to clamp this with both screws, the screw gets wedged very, very quickly. So just 1 or 2 turns in our thread, and then nothing moves anymore. I mean, that might be an advantage because this stop has to be in place and nothing moves anymore is exactly what we want to have in this case. So maybe that works. Also, maybe it's just necessary to clamp it on this side where the lead screw sits. I don't know yet. And if both cases aren't true, what we are going to do is we will go over to the mill and turn this hole into an elongated hole, and this will fix the issue definitely. So let's go over to our lathe and see how everything fits. So welcome back to the lathe and let's see how everything fits. So our stop goes in here and yeah, that fits perfectly, very, very nicely. And now we take the lower bar, put it in here. That might be a little bit fiddly. Actually, it's not. And then that fits. So now we could drive our sled to the position we want. Then put our stop next to it. Tighten it. And let's see. Yeah, this thing is rock solid, even with only one screw. So our little hiccup over here won't be a problem anymore. And now as we have the measurement locked in, we can just, for the next part, drive right up to this point. And when we reach the stop, the machine stops. And so we have the same measurement over and over again without the need to measure. Very nicely. So let's take out another improvement. So you see I put the clocks on our indicators. So let's point this indicator over here and our one over here, and our stop just clicks in, and then we have a slight problem. Okay, yeah, this part should be higher. Just a second. So I just put it on a little pedestal, and now you can see as I move, our indicator moves as well. And we can read off our measurement. Very nice. And lastly, this little holder, and yeah, this fits perfectly. So, a little bit of super glue on our part, and let's just position it. And a little bit of activator. And now we can push our indicator next to it. Of course, we would, in a normal case, would zero it. And now you see, as our sled moves, we can read off our measurement directly. And there you have it. Now with a stop and working indicators, it will be a lot easier for us to turn out all the pins for our rotor. And what I'm going to do in between, I will probably machine a second stop so that we have one for the backside and can log in both measurements. And I also will fix the height issue of that indicator. And lastly, I'm going to attach our collar chuck to the lathe so that we have an easier job of gripping our round stock. So that's basically it for this video. I hope you enjoyed it. If you have questions, comments, as always, let me know down below, and I try to answer them as quickly and correctly as possible. Don't forget to like and subscribe. And all that's left to say now is thanks for watching, and see you at the next time. Bye bye.